automation. It's focused on enabling people to do formal since 2020. LUBIS has been developing a formal on the cloud solution that enables a new audience to do formal verification. Over to you, Tobias.
When I was 14 years old, I got a small yellow book like this that taught me how to develop web pages with HTML and PHP. That was in 2002. And I started doing that, and as soon I was developing web pages for all sorts of clubs, restaurants around my area. I come from a very small town, so at some point people knew me for that. And I kept developing software through my entire career. For some reason, I don't even know anymore how it ended up to be like that, I started studying computer engineering. So when I was finishing my degree, or about to finish my degree in 2014, I was pretty much ready to leave the industry because I realized after doing some internships that first of all, the tools look like the stuff that my father used to use when I was a child. Second, they still develop tests and code the way I developed my first web pages when I was 14 years old. So I applied for jobs, but in parallel, a professor who I've done work with, his name is Wolfgang Kunz, he's big in the believer in formal verification. He asked me, hey, Toby, why don't you do a PhD with us? And I said, I don't know. He said, hey, look into what we have. And I found a guy who came up with a theoretical concept that we use properties in the same way that we use unit tests in the software world. And he called it property-driven development. And I said, that's it, I'm going to do it. I'm going to revolutionize the hardware world. And here we are today. And I want to show you how you can make your own bug detection machine and how you can learn something from the software world. So let's say you have a design and you want to verify it. What I will explain you today is a concept. The cloud could be on-premise or on the cloud, it doesn't really matter, but we need parallel compute resources a lot. And once you have it on the cloud, you have an automatic way to figure out, well, what is the design actually doing? And do I already have something that can verify my design in my verification library or something that is very close? And if yes, can we automatically configure it to run? Then next, you want to have in your library formal tests that give you quick results and concrete results that find bugs. So either after the first run, no bugs, so we're good, at least for the stuff that we checked, or you find a bug, you fix it, and you run again. We talked already today about CI/CD, and we basically done that for formal verification. So today we're going to talk about how we use large language models and how we don't use them. And I'm going to give some insights on why the way we actually develop our assertions, if you want such a flow, is critical. And lastly, I will talk about what I think would be a good solution for the industry when it comes to establishing a modern CI/CD flow. Now, let's start with the easy one. So the key takeaway from today is you want to verify all comment blocks with formal. I don't think we should negotiate on that. If you have comment blocks not verified with formal, yeah, you're in danger. Yeah, if you're a formal expert, don't do repeating tasks. Yeah, so you have to fill your schedule with some sort of automation. And lastly, I think if you want to make formal feasible, we need big compute machines. We need the cloud. We need massive parallelism. So how do we get from having a source code to having an automated formal run? Well, everybody says, yeah, well, let's just use AI. But I think AI, when people talk about it, they have this idea that you put the simple idea in and you get a complex solution out. the effect of that you can see every day on LinkedIn when you have this crazy marketing post with lots of text. And when you start reading, you're like, oh yeah, that's valid English, yeah? That's proper English. Grammar is right, but it's void. Like it has no information. It just creates a lot of noise. And my opinion is, although maybe people have other opinions on it, that would also happen if you ask the AI to generate your properties. So I don't really believe in that, but I believe that AI can help us. So what I would do if I were you, I would use the filter characteristics of the LLM, because at that it is pretty good at. In the end, all you need is a design that you want to test and a library of verification solution that you already have deployed. And then you ask the LLM smart questions. And one question won't be enough. You need to have some sort of iterative prompting based on the results that you get. But in the end, you can ask the LLM pretty much anything. It will be very good. If you give good input in, then in the end, you will get good input out. And we've done that and we do it. I can show it to you later if you want to. It's a fully automated Zapper. You don't need to do anything, but you need to have good quality verification apps. Let's take a look at an example. People like examples. So we have a ambiguous DOT that does something. It's hard for me to tell. I actually talked to my designer. I said, I'm not sure if this actually does what it's supposed to do. But they said, yeah, trust us, Toby. We verified it. Like I said, okay. Does anybody directly see what it is? It's a round robin arbiter. And let's say you have such a code, and round robin arbiters are not always in reality a piece of module that you instantiate. Sometimes the designer just implement them on the fly because they need one. And if you have such a large language model, you can use ChatGPT for it if you want to. And you have a round robin arbiter app and a smart prompting, then the LLM will for sure figure this out, will instantiate your round robin arbiter verification app and automatically trigger the run. And that takes no effort at all once you have the flow set up. And those are the low-hanging fruits that most of the formal experts are busy today within your companies. Yeah, that takes a lot of time, but it should not take any time. You can see here, the LLM figured out, yeah, A is our requesters, B is our grant. And then if you have a good round robin verification app, let's go. Yeah, that's all you need to do. Now, we have finished the setup. That's the critical path. That's what annoyed us the most. So once we got that done, we were like, okay, what can we do next? And everybody probably knows this picture, or most people do. CI/CD flow. It doesn't work in hardware, right? We have to have something else. We don't release, we don't deploy, we don't operate, and we can't monitor. Yeah. So we only have one shot of deploy, operate, and monitor, and that's after tape out, right? So before that, we are still in some sort of planning phase. But we can still adhere to that idea, and I reduced the whole flow to basically having a plan, a design, and a continuous verification. And the analogy that I want to put here is that why does CI/CD work for software well, in my opinion? Well, because they have super fast unit tests. Everybody's unit testing their classes, their modules, like crazy. Like every single line of code is covered by a unit test. And they execute quickly and they find bugs quickly. And we need the same thing for hardware. And instead of using unit tests, we use formal properties. Again, people like examples. So let's make it a little bit more concrete. Let's say you develop a software and it is an accelerator for a car. It's a small piece of code, right? And you would test it. If you write a unit test, this is now the Google test framework, but there are others, of course. You would basically say, hey, let's set the speed to 50, accelerate by 20, and I expect that my car gets to 70 in the end. Yeah. You would run that test. It would take a microsecond to execute. It would be super simple. And we should do the same for hardware. And this might be a little bit more time consuming because you need to write a lot of them. But it is possible if you build up your verification library from the ground up. We can write a formal property, and I guess there are some courses on formal today. So if you don't know yet how to debug it, it basically just said, well, we want to accelerate. And the nice thing about formal is we don't even need to figure out a certain value. We just say, if we want to accelerate, then our next speed needs to be the current speed plus the acceleration amount. And the tool will exercise all cases for you, and we'll see, is there any edge case where it doesn't work. We do that, and if you follow this approach closely and you write a lot of properties, you may end up in situations where you have thousands of properties for an IP, yeah? And if you just run them on one server, you're doomed. That will take forever, yeah? So you need a lot of compute to do that. So if you're a big company, probably you have it. If you're small, medium enterprise, probably you don't. So you may want to look at some cloud solutions here. Now, I said earlier, the tests need to pass fast because otherwise CI/CD doesn't work. If you need to wait for 2 weeks for your verification time to finish, that's not going to work. So we want to look at properties that are easy to execute. And there are some common mistakes that can happen when you look at properties. And that is, the properties are too complex. So pay attention today if you join one of the formal classes, how to write good properties. And one key thing that you can do, it's super easy, but that also you only want to do with a good automation framework in place. This is what a normal person would write. Jump and link instruction is executed. Well, then I check my DUT against my expected results, right? Super simple property, 3 lines. What a normal person would not do is split this property up into smaller chunks, but that helps the formal tool actually a lot. So when we write something like this, we would actually write 3 different properties. Now you tripled the amount of properties and you need to run them. But as I said, if you can fully parallelize it, you're going to be faster in the end overall. There are more tricks to this. So if it's interesting to you, feel free to reach out to me later. Now, let's piece it all together for the example of RISC-V processor. But you can basically plug in anything in here that you want. We developed the same thing for caches, for all sorts of bus bridges. It doesn't really matter, yeah? In the end, you just connect your DOT with your formal checker. In this case, it's a RISC-V formal ISA checker. And you tell the tool to check if everything works correctly. And the nice part is, everybody knows here probably, it's symbolic execution on the input. So all sorts of traces are considered. And with this example in mind, we can nicely see how the CI/CD unit testing pipeline idea can help us to actually get to where we want. So after we set up automatically, we run automatically our static checks. That's a low-hanging fruit. That doesn't cost anything. And if that is okay, then we go into a parallel execution mode. We don't only split up the proofs of the property. If we now look, for example, at instructions, we try to get as many small proof units as we can. So in case of RISC-V, we of course want to have a check for every instruction, right? And what the software world does, they run everything in parallel and they even have gated checks. So there's no point in running multi-instruction checks that actually allow many, many instructions to execute if you can't even pass the single instruction checks. And if you deploy a flow like this, you can always try to implement behaviors, scenarios, before you actually go to the completely unconstrained cases. And that way you get nice converging proofs and you also have some predictability in your execution. Lastly, we compute coverage, release everything, and it's 2024. This has to be web-based. For me, it's still mind-boggling why we still use Tickle and all sorts of VI so much. I'm used to use the web. Yeah? I wrote my whole PhD thesis on the web. And after releasing the result, there has to be a website where you can just log in and get the data. Yeah? And I don't want to log into remote servers anymore. I still have to do it, but that's my big vision that 10 years from now, we use the web. I mean, the results are at hand, yeah. We find these results in all sorts of blocks. Once it's done, the setup is super quick, which usually takes already a couple of days. Then formal finds bugs super quickly, so you don't only have a short setup. If you have the right pipeline in place, you even get results super quick. And if you split them up correctly, as I told you, and you do all the formal trickery, then you usually even get converging proofs. So that's the nice part about this flow. Last year I talked about other ways. So of course, for RISC-V, we have a very, very precise spec, and you always do the same thing. But the question, of course, is where do you get your verification apps from, right? You need to check against something. You can come up with other flows like this, where you have a property generation flow. There's many companies out there doing that right now. you feed some sort of model in. It could be C++, it could be Python that you use as a base for verification. Also, those models are smaller and easier to review. So it's quite easy to do just in-person review on those blocks. You generate your IP, and then the flow stays exactly the same. Yeah, you ask the LLM to connect everything, feed it into the formal tool, and get it done. The important part is that we build this AIP library. Yeah, we need to build it up. The big vendors offer a lot of stuff, but probably your company needs more. So you need to start from the ground and then build your way up through the layers of your blocks. Yeah, and when you do that, in the end, you have a good benefit out of it. If you talk to guys from Intel or ARM, they do that already. So if your company is not doing it, you should get started. The important part about it is that even though the properties, if you generate them, they're not that readable, it doesn't really matter because you still have your model to check against. You can always relate to where from my model is this property coming from. So here on the left-hand side, for example, we feed in a C++ code and we generate the assertion here on the right. And if it fails, we can directly mark and say it's coming from this execution path in the code, from this loop iteration, and there's something wrong in your design or in your model. Yeah, that's of course always the question. I didn't talk about the company. I like to do it in the end, yeah, because I guess most people don't really care about the company. They want to see solutions and examples. So we are a team of 20 people. We just hired our first IT engineer, 1st of June. So now we have a person who's taking care of all of our problems. I'm pretty happy about that. We stem from a background of formal verification consulting. So we started in 2020 with 3 PhDs from the area, motivated to bring more formal. But also we had software engineers on our side. So about 30% of our company is actually software engineering. And anytime we found a problem in our consulting work, we said, software engineers, implement the automation for that. And the flow that you see today is basically the outcome of 4 years of hard and time-consuming consulting work. That's it. That's all I have for you today. So thank you very much.
Thank you, Tobias. Is there a question? There's one online, so I can ask the go to the online one. Is the idea you presented, is that only working for formal verification?
The same flow, of course, works for other sorts of verifications as well. The only important thing is that you have your verification library in place. That's okay. Basically all you need.
And does it work for all sorts of IP?
In theory, yes. But as we may know, if you throw in an entire SoC, probably it's not going to work out of the box. So you need to do some slicing on the blocks.
Okay, perfect. Okay, thank you.